This is fundamental problem 17 from chapter 12. A particle is constrained to travel along the path if x is equal to 4 times t to the 4th meters, where t is in seconds. Determine the magnitude of the particle's velocity and acceleration when t is equal to 0.5 seconds. So we have x is equal to 4 times t to the 4th. We want the magnitude of the velocity and the magnitude of the acceleration. T is equal to 0.5 seconds. And the path that the particle has to move along is y squared is equal to 4x. And I'm kind of disappointed when they do this to us. So if y squared is equal to 4x, y is equal to the square root of 4x. The square root of 4 is 2, so we could write that as 2 times the square root of x. And I know that it's supposed to be positive 2 times the square root of x because of what they show me in the figure here. Okay, so I want the magnitude of the velocity and the magnitude of the acceleration. So I am going to look at my equation sheet for what I have for velocity. So velocity is equal to x dot I hat plus y dot j hat. And actually, I'm just going to write that because this is only in 2 dimensions. And after I find the velocity vector, then I can find the magnitude of the velocity. And I would do that simply by saying the magnitude of velocity is equal to, vx squared plus vy squared. Okay, so what I have to do first is find x dot and y dot. I have x here is equal to 4 times t to the 4th. So x dot is just equal to the derivative with respect to time of 4t to the 4th. So that would be 16 times t to the 3rd. That wasn't too bad. For y dot, that would be the derivative of y with respect to t, but this is what I have for y, so that's the derivative with respect to t of 2 times x to the 1/2, or the square root of x. Now, we could do this using the chain rule. We could say it's the derivative of 2 times the square root of x with respect to x, but then we have to multiply that by dx dt, so you could do this using the chain rule. But you have another choice, which is probably easier. So that would be to take, here it is, x and put it in, well, take 4t to the 4th and put it in for x here. So that would make y, which is equal to 2 times the square root of x, equal to 2 times the square root of 4 times t to the 4th. This is quite easy to do. The square root of 4, as we just did up there, is 2, so that's 2 times 2 outside the square root, which is 4, and then t to the 4th, when you take the square root, would be t squared. Okay, now I can just say dy dt is equal to the derivative with respect to time of 4 times t squared, which is 8t. Okay, so that wasn't too bad. Honestly, doing it this way probably isn't that hard either. But I kind of like knowing what y is with respect to t. Okay, that's it, kind of, for the velocity. So I have x dot, I have y dot. So the velocity is equal to, let's just write this again, x dot I hat plus y dot j hat. So that would be 16 t cubed I hat plus 4t squared j hat. I could find the magnitude of the velocity now, but I think before I do that, I'll just go ahead and find the acceleration. From my equation sheet, I have the acceleration here. Oh, this is, okay, so these equations, remember I showed you, we had to put a few things together to get what we had here. So this is 12-11 and 12 put together to give you this equation here. So that's why it's in italics and there's 11 and 12 there. Same thing here. This is equations 12-13 and 12-14 together to give you this equation here, which is, I think, more useful. Okay, so the acceleration is equal to x double dot I hat plus y double dot j hat. Well, we already have x dot and y dot, right? So we just have to take another time derivative. So x double dot is the derivative of x dot with respect to t, which is the derivative of 16 t cubed with respect to t, which is 48 times t squared. Y double dot is the derivative of y dot with respect to t, which is the derivative with respect to t of y dot is, oops, we'll put that in parentheses, the derivative with respect to t of 8t, which is just 8. Okay, so then the acceleration is x double dot is 48 t squared, that's in the I hat direction, y double dot is 8, and that's in the j hat direction. Now, if I were asking you this question, I'd probably just guess what the velocity and what the acceleration is. Okay, so we have our velocity vector, we have our acceleration vector. I don't feel like there's a whole lot of benefit in taking that and then finding the magnitude. It should be easy to do, but we do have to do it here because that's what they asked us to do. So just to conclude then, the velocity is, we have to put in 0.5 seconds for the time. Let's do that first. Okay, so the velocity when t is equal to 0.5 seconds is, here's my velocity vector. So this is 16 times 0.5 seconds cubed in the I hat direction plus 4 times 0.5 seconds squared in the j hat direction, which gives me 2 I hat plus 4 j hat, and its velocity and the units would be meters per second. Okay, so then to find the magnitude, that would be the square root of 2 squared plus 4 squared, and that would be 4.47 meters per second. So there we have the magnitude of the velocity. For the acceleration, which I'm going to try and squeeze in on the bottom of the page here, the acceleration when time is equal to 0.5 seconds, here's my acceleration, so it's 48 times 0.5 squared in the I hat direction plus 8 in the j hat direction, so the magnitude of the acceleration, oops, maybe we should say this, so that's 12 I hat plus 8 j hat, maybe do on your calculator to check to make sure that works out, and we have 12 squared plus 8 squared, take the square root, that's the square root of 208, which is 14.4 meters per second squared. Okay, and you might just want to run through the calculations on your calculator to make sure everything works out. That's what we get for the magnitude of the acceleration, and that concludes Fundamental Problem 17.